At a distance of about 4 kilometers from Tamil Nadu's Kodaikanal, on the southern tip of the Palani Hills, lies the Kodaikanal Solar Observatory of the Indian Institute of Astrophysics, an autonomous institute of the Department of Science and Technology. The observatory was established here in 1899 by shifting all the activities of the Madras Solar Observatory. Since then, this observatory is studying and observing the sun at different wavelengths. The observatory has many telescopes like the 60-centimeter reflector tunnel telescope, twin telescope, white light active region monitor, spectroheliograph, which has been here since 1904. And H-alpha telescope, which was installed here in 2014. The observatory has a rich history of taking solar images and films at calcium K, hydrogen alpha and white light on photographic plates and films over a century. And these are the only uniform observations of the sun available in the world for the period of 1915 to 1965. These archives are also an important tool to measure the magnetic activity of the sun. Therefore, they have been digitized at the observatory.
Systematically for every day, several images have been taken. So we have digitized all these images over the 100 years, which were taken in photographic plates and later on in films and so on. And now it is all in digital form.
Using the digitized solar images from 1915 to 1965, a team of scientists led by Professor Dipankar Banerjee has reconstructed the magnetic field map of the sun, corresponding to the 5 decades of the last century. This effort will also help in understanding the polarity reversal of the sun, which occurs at every 11 years and shows a distinct pattern that repeats over time.
We have now constructed this map which allows you to sort of study how this field is coming in the surface and how it is decaying with time. So there are certain other properties also being studied from this magnetic map. Why sunspots appear at certain latitude on the solar surface, and then with the progress of the solar cycle, the stronger field goes to the equator, whereas the weaker field goes to the pole. And then there is another element happens every 11 years, the sun's polarity also reverses. So when does this polarity reversal will happen? You can only indicate when when these diffuse field, which will go towards the pole. So these magnetic maps are actually providing you a very good timing information also in terms of the polarity reversal.
The map, developed with the help of 15,000 digital images of the sun, can predict the future of the sun by throwing light on its past behavior. Sun is the primary source of energy that sustains life on the earth. Therefore, our future depends heavily on the destiny of the sun. Developing a magnetic field map is essential to study the patterns of the magnetic activity, and to refine their map, scientists also plan to use data from other observatories.
So this is the first map of its kind. We are expecting next stage to even include data from other observatories. So this is entirely done from Kodaikanal data, but now we are going to combine the data from the Mount Wilson Observatory, which is in US. So you can imagine that when you improve the quality and the statistics in terms of taking data from different sources, cross-calibrate, your next result will be even more refined.
Similar to climate studies where meteorologists need data regarding rain patterns, temperature, etc., astronomers need information on the behavior of the sun in the past to predict how it will behave in the future. A critical parameter of this behavior is the magnetic field, which keeps varying and governs the long-time changes in the sun. Technology today has enabled direct observations of magnetic field, but there are no direct observations of magnetic field recorded before 1960s. Therefore, the recently digitized data of the 121 years old Kodaikanal Observatory is of immense value, and now it is available for free on the website of the observatory.